All right, here's the lecture and notes for classifying metals. How do we define metal? That's an interesting concept. How do people define metal? We had to define metal in regular terms. It's a hard, strong, tough material that can withstand heat without melting. Now, what does a metallurgist do? Or what is a metallurgist? Do we know? Do you have any idea? Well, a metallurgist is responsible for developing metals with special properties that will do a specific job better. So these people are the ones that are constantly coming up with new metals. Okay. They're the ones that are combining different things to see what they can come up with to make things better. If you look at golf clubs, for example, early golf clubs are made out of wood. Drivers, large woods. But now they have titanium drivers that are super light. You can swing really fast. So this is how metallurgists has changed the golfing industry. Now, all metals get put into several classifications. The first classification is ferrous metal. Okay, ferrous metal. Then you have non-ferrous metal. Precious, high temperature, and you have rare. Now we're going to go through all these individually and talk about different types. Now, ferrous metals, probably the most common one out there. This type of metal contains iron. Basically, it's their basic ingredient. So that is, iron has got to be inside it to be a ferrous metal. And a lot of ferrous metals are a mixture of two or more metals. So it's not just one type. There's mixtures in there. One type of ferrous metal that you see a lot of is called cast iron. Cast iron has certain characteristics about it. One, it's extremely hard. It is very brittle. Now, the term brittle, what does that mean to you? Okay. All right. Brittle would be considered like taking a candy bar, putting it in the fridge or the freezer, pulling it out after a couple hours, and then breaking it. Okay, it won't bend, it's just going to snap. That means it's very brittle. Okay. And cast iron has excellent wear resistance. And when we talk about wear resistance, it can withstand heat without losing its form. Now, there are types of cast iron out there. One is malleable iron. Basically, white cast iron that is heated up and cooled under carefully controlled temperature and time. Okay. So basically, they have to heat up white cast iron and just let it just cool off on its own. Okay. The other is gray iron. It's the less expensive of the two. And this one can flow into intricate mold passages and form complex shapes. Old car or engine blocks are made of gray cast iron. Okay. A lot of heavy machinery presses, early and late, are made of gray iron. Okay. White cast iron. It's extremely hard. Okay. And these are used in applications requiring wear and abrasion resistance. Bearing housings would be white cast iron as an example. Another ferrous metal is wrought iron. Now, what is wrought iron? It's an iron alloy that has most of the carbon removed. So if it has most of the carbon removed, these are some characteristics that it has. It's still pretty tough. Don't get me wrong, it's still tough. But one thing about it, it bends very easily. Okay. And wrought iron is mainly used in ornamental work and smokestacks. Now, when we talk about ornamental work, we're talking fencing, gates. Okay. Really, you'd see this in old cemetery gates, fencing, going around old churches. a lot of your decorative fencing is made from ornamental work. And obviously smokestacks, everybody knows what smokestacks look like. Here's some pictures just to help you out, some examples. Okay. This is ornamental work right here, and here's your smokestacks. Now, the other one that goes into the Ferris is carbon steels. Okay. This is classified by their percentage of carbon in points. So this is where you're breaking it down. You're looking at the finer details of this. Okay, there are 3 types of carbon steels. The first type is a low carbon steel. Okay, this contains less than 0.3% carbon. It's very easy to work with. You can weld it. The only one thing about it, the bad thing about it, it cannot be hardened. Okay, it will not hold an edge. Now, simple rod and iron stuff that you buy from a machine shop is probably going to be a low carbon steel. Medium carbon steels, they contain between 0.3% to 0.6% carbon. Hammerheads are made of medium carbon steels. Clamps are made of these. C-clamps, stuff like that. The last one is high carbon steels. That's 0.6% to 1.5% carbon. Many applications that need to be hardened are manufactured from high carbon steels. Knife blades, cutting edges, cutting tools, okay, have a high carbon steel. If you watch Forge and Fire, they're using high carbon steel to make a lot of knives. Basically, you can heat it up and the edge will form. It can be hardened, okay? Now, there are some alloy steels out there, okay? An alloy is a mixture of 2 or more elements. So we're going to go through each one of these alloys that are used in steel. The first one is manganese. In here, if you add it to steel, that purifies the steel and it allows it to withstand shock and hard wear. Purifying makes taking all the impurities out of it. Molybdenum. Okay, you add this to steel when it must remain tough at extremely high temperatures. Okay. You probably will never run into a moly bar at all, but maybe you will. I don't know. That, depending on what you go into for a career when you get older. Chromium. This is the basis for stainless steel. When you add chromium to steel, it will give you toughness and hardness, and it will be excellent wear resistant. Okay. Chrome mags. Okay, stuff that becomes really shiny has chromium in it. There are more. Nickel. Okay, and when you add nickel to steel, you're going to imparts toughness and strength to steel, withstand shock, and it's corrosion resistant. A lot of guns nowadays, pistols, have a nickel plate on it. Okay. Once again, corrosion resistant. Tungsten. When you add tungsten to steel, this makes steel self-hardened and withstand high temperatures. A lot of tungsten is used in making of cutting tools. All right. The last one is vanadium. Okay, used to make steel tough with a fine grain structure. So if you add this to it, it changes the grain structure of your metal, allows it to be a lot tighter, so it's a lot stronger. Now, tool steels. You're going to run in this no matter what. Okay. Tool steels, it's basically tough steel used to make cutting tools. These can hold an edge. Now, there are types of tool steels out there. Okay. There are high-speed steels, which is the acronym HSS. This is probably the most common one. You can find it in drill bits you buy from the store. All right. It will stay right on the drill bit, HSS. Now they've come up with tungsten carbide bits. It's the hardest man-made metal. These cutting bits are much more expensive, probably 3 to 4 times more expensive than high-speed steels. Okay, but they last a lot longer because they're a lot tougher. Okay, you can wear down an edge on a high-speed steel, tungsten carbide. If you break it, you've earned every penny of that. You have to try to break these because that's how tough this stuff is. Now, obviously, the hardest and the toughest tool steel would be a diamond. Okay, but that's really not a ferrous metal. Now, stainless steels. We're still in ferrous metals right now. One important fact, this basically contains enough chromium to make it resistant to corrosion. Now, when you go in and you buy stainless steel silverware, this is what you're getting. But there are actually 3 types of stainless steels out there. The first type is austenitic. The second type is martensitic. And the third is ferritic. Okay. I bet you didn't know there were 3 types. You just thought stainless steel was stainless steel. Okay. Now, austenitic, it's non-magnetic. It's probably the most popular one, and it's used in chemical plants, power plants, dairy equipment, and food processing. All right. Stainless steel knives, stainless steel forks, blades, okay, all your dairy equipment. So if you work on a dairy farm, most of those pieces of equipment are stainless steels, but it's a austenitic stainless steel. Martensitic, this one is magnetic by nature and used mainly when you're requiring some kind of welding. Okay. Ferritic, it's magnetic, used in your sinks. If you have a stainless steel sink at home, this is a ferritic sink. Mufflers and kitchen counters. Okay, that's where you would find those. Now, when you go in and buy steel, you go to a steel mart, you go to the machine shop, you go in and ask for a 5/8 inch diameter round stock. They will ask you this question: do you want hot rolled or do you want cold rolled? Now, there is a difference between the two. Okay. Hot rolled steel and cold rolled steel have different characteristics. Hot rolled steel, it's shaped when it's red hot. It has a blue-black oxide coating, okay, which makes it distinctive. It's very distinctive. And it's not round. Because of the blue-black oxide coating, which is called a scale, your rod is not perfectly round. Now, if you go in and buy a cold rolled, you're looking for a fine finish. It's perfectly round and it's shiny. Okay, so those are the differences. Now, we have to identify certain steels in the shop. How do you go about it? Well, one, you can do a chemical composition, which none of you guys are going to do. It's just a lot of work. Mechanical properties. Now, this one you could do. You could look at it, test and see if it bends and stuff like that, color, stuff like that. AI, SI, SAE codes. This is used all over the metalworking industry. Okay, they have a certain code, 60, 50, 51, bar stock, stuff like that. Okay, they have different codes to designate different types of metal. And then you can do color coding, which is probably the easiest. The ends of the metal are painted a different color. You look at the chart, it'll tell you what it is. And the last one is a spark test. Okay.